Next PCB is a leading provider of reliable PCB fabrication and assembly services for engineers, startups, and businesses worldwide. Specializing in quick-turn prototypes to mass production, we offer multi-layer, HDI, flex, rigid flex, and metal core PCBs with strict quality control and superior customer care. Our advanced facilities ensure reliable performance for applications across consumer electronics, automotive, medical industries, and more. Embracing Industry 4.0 digitization, we streamline the entire electronics manufacturing process to give you competitive pricing and fast lead times, without compromising on quality. And our user-friendly online platform provides instant quotes, order tracking, and full transparency. In addition to PCB fabrication, Next PCB offers comprehensive PCB assembly services including global parts procurement, testing, certification, and box builds. Our 36 automated assembly lines include advanced inspection tools such as SPI, ALI, and X-ray, reflecting our commitment to quality and reliability. Choose Next PCB for exceptional electronics manufacturing solutions you can depend on.
From the Lab Rats Engineering and Electronic Tutorials YouTube channel, click on the More page, or that brings up our mission statement for our purpose here at Lab Rats. Gives you several links. One link is to our webpage where you can buy cool stuff, visit the Geek Shop, get t-shirts, hats, coffee cups. You can donate to our coffee fund through PayPal. Any amount will be greatly appreciated. Jameco is where we bought the power supply. You can click on that and go there, and we will here in a second. And you can click on the Next PCBs, our sponsors page. Every time you go visit them, that will help us out as well. It's very interesting. They are the PCB printed circuit board assembly construction answer to all your needs. This comes up to here. You can see it's Jameco. And then we type in 206, 206, 26. That's our model number. Here's that power supply right here. It's currently on sale. Click that. For $27.96. This is December 2025. So it's probably just for Christmas. This is what we're going to build. So we will go ahead and order it, set it there, and pay for it how you will. And when you receive it, open your box and then come back to this video and we will assemble the power supply. We'll go over all the different components. We'll use our oscilloscope to see the signals as we construct this supply. And it'll be a great addition to what we've already covered, but you'll actually get to see it and use your test equipment to test it out. All right, thanks. Okay, well, now we're going to begin part C, the final assembly of the power supply board before we turn it on and actually start using it. Here you need to pay especially close attention to how the ICs fit into the board with respect to the heatsink. Don't tighten down the heatsink to the IC until you already have soldered into the board and have the heatsink firmly flush to the board itself. On the LED, make sure you have the flat side pointing in the correct direction. So that'll be pointing towards IC2. And the capacitors on the titanium, I don't think they have a plus and minus side because they're titanium capacitors. So make sure you just put those in correctly and follow this diagram to the T. Okay, let's get started. I've laid out all the parts here on our cutting table. We've got the cutting table so the hot solder doesn't touch the anesthetic pad. We got our heat sinks for our TO220 case, the LM317T, the positive supply. LM337T. 33T, the negative supply. Our 2.5K quarter watt potentiometers, which will be used to adjust the voltage output. Our quarter watt 180 ohm resistor that works in series with the potentiometer. to bias the output. Our 1/4 watt 1K ohm resistor used to limit the current going through the LED so don't burn it up. This will let us know we have power to the power supply. And our 2 filtering output caps. Our titanium output filters have 1 microfarad. Our connection set, the screw and nut set with a lock washer, which will attach the voltage regulating ICs to their heatsink. Here's our power supply that we're going to use. We're going to go ahead and install all the components first, and then by installing, I mean by inserting them into the holes, and then I'll come back by, flip the power supply over, and solder everything together. Okay, that's it for that. Okay, we're going to install the potentiometers next. As you could have seen in the video prior to this, I was having a little trouble with it because you got to bend the leads to fit into the holes they have. So I want to show you what you need to watch. Now see R3, this is the R2, this is the 180 ohm resistor. This is R3, it's acting as a rheostat. This is pin 1, pin 2, the middle pin, and pin 3, the outer pin, as we're looking into it. Now you have to bend this pin 2, bring it in a little bit and then down so it'll fit in the hole. But be careful because I'll show you why in a little bit. But R4 is the same way. It's a rheostat as well. Here's your 180 ohm resistor. The pin 3 and pin 2 are shorted, and pin 1 goes to ground. That makes it a rheostat. So we're going to look at a picture of the actual layout of the potentiometer, and then we're going to install it. Okay, we're going to look at the potentiometers right now, the physical layout. This is not exactly like what we have, but it has the same principal layout. We have pin 1. Pin 1 is a fixed end, as you can see, and if you look at the diagram to the right, it hooks to one end of the resistive track. Next pin is pin 2. It's a wiper pin. As you can look in the picture to the right, the wiper pin rides on the resistive track, allowing you to place it at different resistive values on the track. The last pin is pin 3, and it's hooked to the opposite end of the resistive track from pin 1. Now when you install this, or you're bending the pins to fit into the holes, be sure you don't crack the resistive track. Okay, let's now install the potentiometers and the red LED with its 1K ohm resistor. assembly of the power supply. We're ready to turn it on and test it. There's three things that I did incorrectly when I was assembling this board. First thing is I didn't clean all the leads good enough so that they would take solder. So when I was soldering them, I couldn't get them to take the solder, so I had to put resin or flux on the area, and that cleaned it up. The second thing is that I did is I had to widen the holes a little bit. They used too small of a drill bit for some of the holes that they drilled through the board. So I took the end of my tweezers and stuck the needle part into the holes and widened the holes a little bit. That helped quite a bit. The third thing was, as I soldered the ICs in first before I attached the heatsink, which caused the heat sinks not to fit flush against the board. So I unsoldered them, made the heat sinks flush, screwed it all together, then soldered them back in. So let's turn this thing on and see if it works. Okay, let's power it up and see how well it works. We have our oscilloscope on times 10 per division, DC in times 1 probe. We're going to use our digital voltmeter. We got it on 20 volts max. We're going to use our varactor to power it up because something could be shorted, so you will be able to see it immediately. And this has a short protection, so it'll shut down automatically. So let's go. Let's kick this up to 120 volts. There's 120 right there. Our red light's on. It's telling us we have power to our power supply. As we can see on the digital storage scope, which is right there, that we have 10 volts. Nice steady 10 volts. We can see on our DVM here that it's 10.82 volts. I can adjust the voltage out by varying R4. Turning that to the right makes the voltage go up. So that's more resistance I'm putting into the circuit, and then turning it to the left makes the voltage go down. So it'll go from 0 to 15 volts. That's the LM317T right there. And as you can see on the digital scope as well, I turn it to the left, the voltage goes down. Turn it to the right, my voltage is going up. It's all the way out, so that's 15 volts. Let's measure the negative side now. We'll take the scope over to here. It's measuring the negative voltage. There's our DVM. As you can see for the DVM, we're measuring at negative 10.91. The oscilloscope from this right there is the 0 point. That shows you that we're at negative 10.9, almost 0.9. So let's move the rheostat here, which is R3. We'll move it to the right. Causes the negative voltage to go up. As you can see, it's at a negative 19. It's a little higher. It'll go from 0 to 20, I guess. And if we move it to the left, reducing the resistor, we can go down to 0 volts. So there you go. You have a really nice 1 amp, maximum probably 1.5 amps, dual adjustable power supply. Enjoy.